Hello everybody, welcome into another lesson. Today we are going to introduce variables for the first time. Well, what are variables exactly? You could think of them as unknown numbers. Those are unknown numbers. So let's say I have m plus 12 equals 12. M is unknown. We do not know what m equals. You may see other variables. Most common one, it's a favorite of algebra, is x. You may see y. You could see z, a, you name it. You could see any of the letters of the alphabet as variables. So the numbers are called constants. The letter is a variable. So there are two ways we could solve variable equations. We can do the first one as trial and error. What do I mean by trial and error? Well, we can stick any value in for m. We put in some random value for m and see if the left side equals the right hand side. So we'll start with m equals 2. Now let's not do that because I don't want to confuse it with being the answer. So let's put 2 in place of m plus 12 and see if that's equal to 12. Well, last time I checked, 2 plus 12 was 14. Does 14 equal 12? No, we got a false statement, so it certainly can't be 2. Alright, how about if m's 1? So we'll have 1 plus 12. Is that going to be equal to 12? That has yet to be seen. Well, 1 plus 12 is 13. We know 13 also does not equal 12. That gives you a false statement about 13 equaling 12. Well, how about m equaling 0? If I put 0 in place of m, I have 0 plus 12. Does that equal 12? Well, yeah, any number plus 0 is itself, so 12 equals 12. We got a true statement. We could say m, in fact, equals 0. I put a box around it to signify that's a solution. But that was one way to do it. So, are you really going to want to sit there all day and do trial and error and plug in numbers? I don't think so. Here's the second way, which is the best way to do it for any unknown numbers. So we have m. We want to get that by itself. You want to get m by itself on one side, the numbers on the other side. Well, we have m plus 12. We need to get rid of that 12, don't we? So the only way to get rid of 12, you have plus 12, is you need to minus 12. So we'll have m plus 12 minus 12 is equal to, now what you do to one side, you have to do the other. So if I take away 12 from the left side, I need to take it away from the right side also. So we have m plus 12 minus 12 equals 12. Whoops, that should be 12, not 2. Equals 12 minus 12. Okay? Well, that's going to leave you with m plus 0 is equal to, was 12 minus 12. Any number minus itself is 0. Which plus 0, again, any number plus 0 is itself. We got m is equal to 0. Alright, so we're not done yet though. We got m equals 0, but we got to check it. So what we do to check is we put that 0 in, put the value you got for m in place in the original equation. So you put the 0 in for m, 0 plus 12 equals 12. So in fact 0 plus 12 does equal 12, and 12 equals 12. That's a true statement, so m in fact equals 0. Put a box around it, you got your solution. M equals 0. Alright, that's one example here. Okay, how about if we had something like x plus 13 equals 42. So you see there, x plus 13 equals 42. Well, we need to get the x by itself, don't we? If we have plus 13, how do we get rid of that 13? We subtract 13. So you'll do x plus 13, then you'll do minus 13 is equal to, so remember, what you do to one side of the equation you have to do to the other to make it equal. So you'll have 42 minus 13. So let's see, on the side we can do, let's figure out 42 minus 13 on the side. Well, 2 minus 3 doesn't work, so we got to make that a 12. Borrow 1 from the tens place, that's a 3. So 12 minus 3 is 9. 3 minus 1 is 2. So the right hand side is 29. And then we got 13 minus 13 is 0, so we'd have x is equal to 29. However, we need to verify the solution. I'm going to verify it down below here. So we put in 29 for x in the original equation. We have 29, and make sure you can see it a little bit better there. How about 29 plus 13? Let's see if it equals 42 if you get a true statement. I'd work that out on the side, 29 plus 13. Do your addition problem on the side of the piece of paper or a scrap piece of paper. 29 plus 13, 9 plus 3 is 12. Carry the 1. 1 plus 2 is 3 plus 1 is 4. In fact, it does equal 42. We know 42 equals 42. That's a true statement. So x is equal to 29. We can verify that that is the solution. All right. How about another one? We will do y plus 16 equals 61. So y plus 16 equals 61. Again, we want to get y by itself. So how are we going to do that? You're going to subtract 16. But what you do to one side, you got to do the other. So you have y plus 16. Let's do that in different ink. Let's do that in blue ink, eh? Alright, I'm sorry guys. Alright, so y plus 16 minus 16 equals 61 minus 16. Well, 16 minus 16 is 0. You'll be left with y by itself, but what is 61 minus 16? So let's do that on the side here. 61 minus 16. So we know how to do a subtraction now. That 1 becomes an 11. We borrow 1 from the other place. The 6 becomes a 5. 11 minus 6 is 5. 5 minus 1 is 4. So according to this, x should equal 45. I mean, sorry, y should equal 45. But for good measure, I'll use brown here. For good measure, let's do a check of it. So in the original equation, put in 45 for where y is. So we'll have 45 plus 16. Let's see if it equals 61. So off to the side, you'll work your addition problem. 45 plus 16. 5 and 6 is 11. Have the 1. Carry the 1. 1 plus 4 is 5. 5 plus 1 is 6. In fact, we do get 61. So 61 equals 61. That's a true statement. So therefore, y equals 45. We can absolutely declare that. Alright. One more of the addition subtraction type. Then there's another type. Let's see here. Alright. We have 56 plus P equals 92. Well, by the commutative property, if you want to, you could switch P and 56, because in addition, it doesn't matter what order they go in. So you could say P plus 56 equals 92. You can totally do that if that makes it easier for you. Now, again, we want to get the P by itself, correct? How do we get that? You would subtract 56. So P plus 56 minus 56 equals 92 minus 56, okay? Well, 56 minus 56 is 0. You'll get P by itself. Now we need to figure out what is 92 minus 56. So go ahead and work out your subtraction problem on the side. So let's see. We know that 2 becomes a 12. We borrow 1 from the 9. That becomes an 8. So 12 minus 6 is 6. 8 minus 5 is 3. So P equals 36 according to that. But we aren't done yet because we need to check our work. Well, I wanted to use brown. Yeah, let's use brown. That's a better color. Red sometimes is too glary. Okay. So we take that 36. You're going to put it in for P. So in the original equation, so you'll have 56 plus 36 equal to 92. So we'll take this problem here. We'll work out 56 and 36 on the side. 6 plus 6 is 12. Carry the 1. 1 plus 5 is 6, plus 3 is 9. In fact, that is the correct answer, because 92 equals 92. Therefore, it's safe to say that P equals 36. Alright? So these are your basic addition subtraction type of variable problems. Now, so my idea here is don't let this scare you. We are technically doing a little bit of pre-algebra right now, but don't let variables scare you. They're really not that bad. All right. Now we have another type of variable problem here. Let's say I have something like, what about if I had something like this? 3x equals 24. Well, suddenly it's not just x anymore, it's 3x. You could think of that the same as 3 times x equals 24. So if it's 3x, it's 3 times x. And this is why I said get away from using the x as your multiplication symbol. Look how confusing that is. I mean, for most of these lessons, it's okay to use the x as a multiplication symbol, but as you get into algebra and higher, you really don't want to do that. You'll want to use the dot, or you can even use parentheses for the multiplication. That's fine. But, alright, so just know that that's 3 times x. Okay. So, if we want to get x by itself, how are we going to do that? You have a 3. Well, we know any number divided by itself is 1. We'll need to divide by 3. So you'll have 3x. Here, hold on a second. You'll have 3x. You need to divide by 3. divided by 3, but what you do to one side, you must do to the other. So 3x divided by 3 equals 24 divided by 3. Alright? So 3 divided by 3 is 1. You'll have the x by itself now. So what is 24 divided by 3? That's 8. So according to this, x equals 8. But I wonder if green would be a good color. That might be a good color. No, it's pretty blurry. I ain't going to use that. I'm not going to use that. It's kind of blurry. I'm disappointed. I like green. Okay. Let's get a brown marker. Again, like before, you need to check your solution. So into the original equation, you'll stick 8 in for where x is. So you'll have 3 times 8 equal to 24. Well, does 3 times 8 equal 24? It most certainly does. 24 equals 24, which is a true statement. Therefore, x equals 8 is your solution. All right. There's one of those problems down. I got 3 more, and that should be it for the class today. Okay. I have 8n equals 112. All right, so again, that's 8 times n. So in order to get rid of 8 times n, we need to divide by 8. That'll get rid of the 8. So blue ink, remember. Okay. So 8n divided by 8 is equal to 112 divided by 8. Because remember, what you do to one side, you have to do to the other. So we know 8 divided by 8 is 1. You'll have n by itself. N is equal to, what's 112 divided by 8? We need to work that out on the side. Do a little bit of long division on the side. So what is 112 divided by 8? 8 goes into 11 how many times? Once. 1 times 8 is 8. So 11 minus 8 we know is 3. You bring down the 2. 8 times what equals 32? That's 4. 4 times 8 is 32. 32 minus 32 is 0. So your answer to that is going to be 14. N equals 14. But we're not done yet. We want to check. So what we have to do is stick 14 into the original equation. So you'll have 8 times 14 equal to 112. Well, does 8 times 14 equal 112? Let's do a multiplication problem on the side. 14 times 8. Make this a little bit bigger. It'd be nice if you could see it, eh? Alright, 14 times 8. So 4 times 8 is 32. We have the 2. Carry the 3 to the next place. 8 times 1 is 8 plus 3 is 11. So yes, 112. You do in fact get 112 on the left-hand side, which equals 112 on the right-hand side. So therefore, we can conclude that n in fact does equal 14. Now when doing algebra, at some point, like when you move into pre-algebra and algebra, you're not going to have to keep checking your solution. You can know it's right. I'm only doing this to show you it works. Like to start with, I want to show you to check your, I want to teach you to check your work here. Make sure you got it correct. Okay, 2 more problems. We have 5z equals 715. Alright, so again, we have that 5z. We need to get z by itself. We need to get rid of that 5 in front of it. How do we do that? Since it's times 5, we need to divide by 5. You do the opposite operation. So 5z divided by 5, but what you do to one side, you do to the other, is equal to 715 divided by 5. Okay. Well, 5 divided by 5 is 1. You'll get z by itself. Now we need to, on the side, work out what is 715 divided by 5. Okay, 5 goes into 7 how many times? Once. 1 times 5 is 5. So 7 minus 5 is 2. You'll bring down that 1 from the dividend. 5 goes into 21 how many times? It goes in 4 times. 4 times 5 is 20. 21 minus 20 is 1. Bring down that 5 from the dividend. So then you'll have, how many times does 5 go into 15? It goes in 3 times. So then we get 3 times 5 is 15. You'll subtract 15 from 15, you'll get 0, so your answer is going to be 143. And again, for good measure, just for good measure here, let's check our work. Let's verify that 143 is the answer. So you stick that 143 in for where you saw z. So you'll have 5 times 143 equal to 715. Well, is that actually the case? Let's find out. On the side, we'll do 143 times 5. Okay. So 3 times 5 is 15. We got the 5. Carry the 1 to the next place. 5 times 4 is 20, plus 1 is 21. Keep the 1, carry the 2 to the next place. 5 times 1 is 5, plus 2 is 7. We get 715 back. So we can say 715 equals 715, which would be a true statement. So we can definitely conclude that z equals 143. One more problem, then the lesson's over. So what if we have a slightly harder one here? What if we have 11n equals 165? So again, we have 11 times n. We want to get the n by itself. We have to, since it's 11 times n, we got to divide by 11. So 11n divided by 11 equals 165 divided by 11. Okay, whoops. So when you divide 11 by 11, you get 1. You'll have 1n, which that means it's n by itself. Now we need to figure out what is 165 divided by 11. You'll work that out on the side with another long division problem. So 165 divided by 11, how many times does 11 go into 16? 1 time. 1 times 11 is 11. So what is 16 minus 11? Well, that's 5. Then you'll bring down this 5 from the dividend. Now you got to figure out how many times does 11 go into 55? Well, it goes in 5 times. So then we have 5 times 11, which is 55. You'll subtract 55 from 55 and get 0. So it would appear that n is going to equal 15. However, like we should, since we're just starting out with variables, we should check our answer. Now, when in doubt, check it out. That's what I say. And especially when you first learn this, if you're taking a class with a teacher, more than likely your teacher is going to tell you they want you to check your work and check the answer. For good reason. So I'll stick this 15 in where I see an n. I'll have 11 times 15 would be equal to 165. Does 11 times 15 equal 165? Well, let's find out. Let's do our multiplication on the side. 1 times 5 is 5. 5 times 1 is 5. Start in the second row, bring down a 0 by default. Now we can do 1 times 1 is 1. 1 times 1 is 1. Add these two rows together, you'll get 5, 6, 1. You'll get 165. So yes, in fact, 165 on the left-hand side would equal 165 on the right-hand side, which therefore means that n equals 15. All right. So yes, that is our final answer. So basically, you could think of today's lesson kind of like a grand review of addition, subtraction, multiplication, and division. Everything we've done up to this point. It's a grand review. We just introduced variables. But as you see from this, solving basic variable equations like this really isn't that bad. It's really not that scary. It sure beats sitting there trying to pull the numbers out of the air and plug them in all day with trial and error. That's for sure. But next lesson, we will actually do some word problems and apply what we've learned so far to some word problems. So I hope everyone has a good night and see you next lesson.